Pardon? Yeah, I can. It's just, it gets up under your chin. It works. Okay, let's see here. I need, this is actually already posted. No, you guys were stunned that something actually showed up ahead of when we were going to discuss it. Hey. Okay. The way I'd like to proceed with these, I've actually got 3 of these that I'd like you to work through. Last time we kind of talked through, I'm just going to go ahead and start from the middle. There's nothing on the front page except the title. Last time we talked through the difference between covering geography and covering users. You know, I can take the radius of coverage of a radio and I can assume my users are evenly distributed, and I just have to make it work geographically. Sometimes it's that easy. You know, if you're dealing with an area where you have to provide coverage, but you know there are not going to be a lot of people most of the time, think our quad, for example, you know, rarely do you have lots of people in the quad. And when you do, typically they're doing something other than wireless stuff. So in that case, you really are just covering geography, you know, and you got to get enough signal everywhere in that geography for the device to work, but I don't have to worry about so many users on each one. And then we talked about a situation that was exactly the other end of the spectrum. I have lots of users in a very small area, and that would be like one of our larger classrooms in Faculty Hall, for example, auditoriums, sports arenas, any place where you have lots of people closely packed. That's going to be an issue. So, and we talked through kind of how we did all that. In both of those, we assumed we were using APs with the same coverage. At the very end, we talked about the idea of using power or antenna gain or something like that to change the radius of coverage. And that's what I want to dig into a little bit today. If we have more complex situations, how can we adapt coverage and get everybody what they need? Now, if you were just dealing with physical coverage, that's one thing. But we also have to do with frequency sharing. So we have to make sure that we don't have co-channel frequencies. We are going to talk about situations where that's okay. There are times when that's a useful thing to do. I'm not ready to talk about it yet. So, for the first problem, what I'd like to do is kind of discuss through this, and I'd like you to say, I'd like you to kind of pair up, if you will, and kind of work through this. Here's the situation. We have a park, and I need to write this stuff, the key numbers on the board. Somebody snagged markers again. The park is about 1,200 feet by 500 feet. There are, at any given time, about 40 users evenly distributed throughout that whole area, just walking around or what have you. There are a couple of areas where we have lots of users at lunchtime, and we want to design to that peak load. In one of the areas, we have 40 or 50 users at peak time. At the other area, we have 60 or 70 users at peak time. So the problem is, how do we service all of those users? Now, I want you to think through this. The APs have adjustable power. What does that mean for coverage? I can increase it or decrease it. Right. I can, and if I decrease power, what do I do to the radius of coverage? I shorten it. What do I do to co-channel interference? I make it so that I can move co-channel stations closer together. Okay? And those are the two things I want you to kind of think through on this. Okay? So power is one way we control that. The other way we control coverage is antenna pattern. Now, before today, for these discussions, we've been talking about omnis only. For this discussion, I'm going to tell you that you have omni antennas and you have panel antennas with a 90-degree pattern of coverage. Okay? I'm purposely avoiding path loss things because the way typically you deal with this is you assume, we'll get spec sheets in here, but you can assume a radius of coverage to about 300 feet at the specs for whatever we're doing in open air. Okay, and so we're using that kind of as a planning number. Now it's a maximum. Okay, so approximately. You know, and if you get to 305 feet, does it fall apart? No. Will moving from 300 feet where it's too weak to 295 feet fix a problem? Probably not. But about 300 feet radius of coverage, max. That's with an omni. The way you interpret that is if you're using a panel antenna at full power, I can push a signal further out that way, or I can control power in the omni to pull signals. So you have two controls over coverage and where signal goes. Okay, here's what I would like you to consider. If you would pair up. If we don't get to all of these today, that's fine. We'll pick them up the next time we get together, because this is the kind of discussion I want us to do. First off, how many APs are required? Notice I didn't say how many are required for geography and how many are required for coverage. How many APs? This is a step closer to a real-world problem. We have two design criteria. We have to provide coverage in that entire park. We have lots of users concentrated in two areas. So now our question of how many APs are required is more complex than if we look at either one of those in isolation. I'm going to say where will they be located, I'm going to give you a great gift. You may assume that you can mount the AP anywhere in the park you want and that the infrastructure cabling is there. Those things are rarely true, but we're going to assume it for this. You will look fondly back on this exercise. What channel will be assigned to each AP? What will the coverage area be for each AP? And as a corollary to that, what design choices affect coverage area? Okay. And then finally, what antenna will be used for each AP and why. Pair off, or even 3. I don't want any more than 3 talking together on this. Work through that a little bit. Think about it. What I want to do when we get back together is go through each of these questions. Pretty obviously, we can't answer any of these in isolation. And what I'm really interested in is getting you thinking about how these things are all interrelated. You don't have to write fast to write all this down. I've got it on the handout for this. That's up. So write down what you need in here, but all of this information is up on the Canvas site. So let's take 10 minutes. Let's see, what time is it? Yeah, let's take 10 minutes and see what you can come up with. You're not trying to get in my head. You're not trying to think what I would do. I want you to think through this together. Please do work together. I'd like you to discuss the solution. At least 2, more than 3. It's 300 feet of radius with the omni. So if I then put it in a directional antenna, what happens to that? Yeah, I take some of the energy that's in 270 degrees of the omni and I put it into that 90 degrees. Okay? So it'll go further in that 90 degrees and less in the other 90 degrees. How far? Don't know. At that point, you're going to have to get out and walk it. It will go significantly further. I can't give you a number exactly. You can safely assume twice as far. Okay? I'll be right back. Good morning. For the online class, I would like you to work through this on your own. We'll have a discussion in a little bit, but work through it for about the same amount of time. If you would, consider those questions, and then I would like you to compare your discussions, your deliberations with the discussions we have in a few minutes.
these only during lunch hours? Because we need to automatically assume that there's always 40 users distributed.
Yeah, I've asked you to design to the peak. So, yeah.
And then the other ones in the corners are like very much.
Yeah, they're, well,
we still assume that.
yeah, I mean, I was trying to make it plausible, so you have to design the peak. Basically, what you're saying is there are always 40 or 50 people in that corner. There are always 60 to 70 in this corner. So, yeah. I'm not trying to make it more complicated that way. You're designing to the peak load for the whole network. I'm sorry. Not made of glass. All right. Need another minute or two, or you want to talk about it? Another minute or two? Okay. think I just solved a problem I've been working on for 2 months on these labs, standing up here waiting for you. Okay, so what are the design issues? What are you having to deal with that's not just a simple, straightforward problem?
Well, having 16 or
What you're exactly right. What's the issue?
well, you're having, since you only have about 25 users per IP, in that quarter you're going to need at least 3 APs.
Right. We've got enough users in that corner that we can't just cover the geography.
Yeah.
Exactly right. Okay. Other issues?
3 channels.
3 channels and a pretty complex world. I mean, we're going to have at least 2 APs to cover this area. We're going to have 3 to cover these users just to get the user service going. And oh, by the way, we've got to do all the rest of this. So how do we do that? Yeah, so we've got an issue with adjacency, co-channel adjacency. Now, let me say up front, there are a lot of ways to solve this. I was sketching around on, in fact, I moved these around until I got it, until you could get at least 3 viable ways to solve this. So, I really do want this to be a discussion. Can you outline what your group came up with?
Like verbally?
Yeah.
Well, first of all, we were afraid of using the panel antenna.
Afraid of using the panel antenna. Why? Would it bite?
We weren't sure.
Oh, okay.
We stuck with the omnidirectional ones, but we actually just had an issue with it.
Okay.
Well, in case you could fix that.
It can be easily
Channel
fixed.
6, use channel 6 here, then
We just have to swap our channels around, but essentially in the center, like to cover the large center
Okay.
area, since we have one large using, I think, 550 total from one side to the other side of distance, because it says that you can have 300 radius, right?
Right. 300 radius. So call it. So something like this. In other words. Actually, I chose channel 1. Which one did you use?
Well, we had 6 written down, but I think we're going to have to restructure the channels, because I forgot about the 40 and 50 users in the top left, and I'll put one API on it.
I'm doing this so that the people in the online class can kind of follow along with what our discussion is graphically. So is this what you had for the center? Okay. And then give me the gist of how you covered the rest of the large area first. How did you? Don't keep working. I want to do the discussion. How did you cover the rest of this and this?
okay, for the bottom corner down there, the computer typing user,
Okay.
you guys had 3 APs, so you put 3 omnis down there.
Okay. 3 omnis.
You have one with channel 1, one with 11, one with 6.
Okay. Let me get those down where I can grab them here.
That's the power we managed to fairly.
Pretty small. Okay.
That way they will.
Where did you put 1?
We put one kind of off to the back there, like where
I should have. One down in the corner. So, like that? Okay. Roughly, I mean, okay.
Channel 6, right to the left of that.
Yeah, 11 where
Okay, so 6 like right there?
6 was more like coming off the wall on the edge of the park down. And then 11 covered the area that 1 and 6 couldn't cover going into the center AP. If that makes sense. And we did that, I guess, to try to avoid the channel interference from the center AP.
Okay. So, something along that line? Okay. Okay, what about these?
40 to 50 users, or do you want to just go ahead and take care of the area?
Either one?
So we did 2 APs up there. Unfortunately, we were doing channels to play with, so we did one with 11.
Okay. Ah. Where'd you put 1?
We just put it in the top.
Like up there? Maybe a little larger.
Yeah, these will give you a little bit more power.
Okay.
Than they need to if they're
Okay, so something along that line. Okay, what about the rest of the park area? Here
In the
and here.
bottom left corner, we had 1 AP that was broadcasting on channel
11, okay.
And then in the top right corner, we had 1 AP.
So big enough to cover like that?
Yeah, and then in the top right corner, we had 1 AP on channel 11. So the whole idea was that, like, in the bottom right corner where 11 is shielding part of 1, they would actually be, like, going out.
So
That way the ones
ballpark something like this.
yeah.
Okay. Now before I do anything else, let me do this.
My drawing kind of looks like a basketball court.
Okay. Okay. Other group. In that case, let me do some erasing here. Okay.
So, on the 2 corners, when we started there, we kind of made squares out of the 2 panel, and then
Okay.
for the bottom right, we made a square with 2 panels, and then put an omni over them.
Okay. Walk me through getting the upper corner first.
The upper left, we put a channel 1 in the corner.
I didn't mean to do that. I meant to copy it. Okay, duplicate. Okay, channel 1 in the corner. I haven't ever done this. This actually works sort of well. I didn't actually get my panels right at 90 degrees, did I? Close enough.
And then put a channel 6 facing it.
Okay.
What would be a square?
Like that. Okay.
And then put an omni sort of below the 6 to cover probably half the left half of
Okay. Which channel?
channel
11. So this was a pretty big coverage.
Yeah, it covers pretty much the left half.
Okay.
But it also overlaps with that corner.
Like that. Even bigger.
Yeah, sort of a little bit more to the right. Because we put another panel in the bottom left corner to cover that area.
So something to that effect. We don't have to get them exactly. Okay.
And then we put a channel 1 down in the left corner of panel.
Channel 1 panel in the left corner.
Bottom one.
Ah.
Cover that whole corner.
Okay, down here, pointed out. Like that. Okay. Other way.
In the bottom left corner is the cover.
Oh, like that. Like that.
No, the far bottom left corner.
Right here.
Yeah.
Oh, okay. I'm sorry. And is that, how far did that go? I mean, pretty wide coverage.
It went like pretty much to that corner, the upper left corner.
Okay. So,
Sort of something like that. Except it wasn't. It didn't get to the.
You didn't get that part.
It didn't get to the other channel 1 panel.
okay. So, a little smaller than I show it. Something like that.
Yeah.
Roughly. Okay. What else?
Bottom left, or the bottom right, sorry, we made another square.
Using,
We did a channel 11 on the bottom right corner.
like that. You got to remember, I don't know my right from my left, and I am not joking. Right hand? Not right hand, okay?
And then channel 1 panel facing that one.
Okay. Like that?
Yep. And then channel 6, I'm going over this.
Oh, okay. So,
There's a little bit more in the corner.
like that, more, roughly. Is that pretty close?
We had a lot more in there, but that pretty much works.
Okay. Okay, let's see here. So, in one solution, we used all omnis. Talk to me about this solution in terms of problems. What issues are with it? Either group.
Are we assuming that they're all overlapping?
Yes.
Yeah, I was going to say, we don't have any of that bottom right. The 6 needs to be in the corner.
Yeah, so we kind of need to maybe flip those two.
Yeah.
Okay. Okay.
It looks a little different in our
Well, yeah, I mean, I realize we're doing this kind of fast and loose.
6 didn't.
Okay.
How was your that zone?
I'm sorry?
Did you run into any of
Yeah, and that brings up a point. This exercise is valuable. You can look at it, and this is the way you'll plan a lot of stuff. It's one thing to put things on paper. It's another thing to put equipment out in the world, which is why dead zones like this might really occur. More likely with this many APs, it's not going to happen. Now, this kind of thing probably will be a big issue, although let's think through this for a second. Where's the AP with an omni antenna? Okay. So talk to me about somebody standing right here. Yeah, you know, this is not, as much as everybody would like to make it where you can design this out to 4 decimal places of signal and predict exactly what's going to happen, you can't. You know, so this is as valid a way of doing this as anything. Just realize, you know, like the way we drew it here, and I realize this is my interpretation of what you were telling me really quickly, we ended up with an adjacency. Our best thing probably would be to flip 1 and 6 down in that lower right corner. Okay? Other comments on this? Have we provided adequate coverage for our users? Yeah. At 25, at a rule of thumb, 25 users per AP. We have. Maybe, you might get into a situation where if everybody clumped together in the middle, we'd have a problem, but I'm not planning on that. I said they were evenly distributed. We're okay. Let's look at the other one. Talk to me, either group. Problems with this? First off, let's see. Does it cover our users? Does it do what we need it to do? Okay. What about the lower right? Do we provide coverage for 60 to 70 users?
Whichever ones are on channel 6 might be kind of small. Yeah, channel 6 is far out.
Those using 6 may be at a little bit of a disadvantage.
Yeah, we had it with channel 6 kind of just covering that area, and then we had more
Oh, you had, okay, okay. Well, given the time we have, let's go with this one and poke first sticks at it. Okay. Problems anybody sees with this? I think both of these are very workable solutions. I like the fact this one uses pattern, uses antenna pattern. It's a little more predictable on things. Let me ask this. Did anybody consider a solution where you did omnis on these two hotspots and panels going in from the edge? Both of these are variations that I came up with something similar to what each group did, and then that was my third variation. Yeah, like omnis down here, counting on strong signal from an omni fairly close by. Panel here, and or here, and panel here, maybe. Kind of keep the edges of the beam widths off of those. So, let's see, I've got a couple. Let me make a copy of this, and I'll go ahead and sketch that one up. I can come up with problems with doing it that way. Actually, let me go up and grab these from somewhere else. 1, 6, 1, 6, and somewhere I've got an 11, 11. Okay, so if we size these way down, maybe not that far down. Looks like a cough drop. And let's see, I'm working this without my notes, but cover these with omnis pretty close in. Again, this is a close counts thing just for discussion, but we need that and that, both of them a little larger. And then take, do your general coverage with this sort of thing. lost the top. And I did it backwards. I should have, anyway. There we go. That's more like it. And then an 11, kind of that one. You could also do it like this. With my time, I don't, you know, we're kind of running up against it, but something along this line. Yeah, 6, okay, trade 6 and 11, that would work. So in other words, any of those three solutions, and there are other variations on it you could do. But in all those cases, we're doing the same thing. We're controlling pattern and having stronger signal where we have more people. We're letting a less strong signal go over a larger area where we have fewer users. Not to the point where we don't have a usable signal. The idea is, and let me actually use the first one we looked at as the example in this, because it probably illustrates it the best. If I have a user on 6 here, as I move away from this point, that signal is going to drop. This is, you know, inverse square law. So as I move away, this 6, yes, we have an area of commingling. Yes, I've got the power turned down on this one. I've also got 2 other APs in here covering that area. So probably that 6 is going to win, particularly if we flip 1 and 6 in that lower right corner. Then I really do have, let me do that real quickly. So if we do this kind of thing, for example, now I've probably not completely cured my adjacencies, but I have other coverage in here. I have a little bit of crossover here, but again, you've got an AP far away, an AP close. We're going to have a good signal from one of them. This is not an exact thing. We're going to discuss through these kind of things and some other solutions. The one thing we haven't talked about in here is what happens vertically. This is a big wide open park. Okay, we're fine. Can you guess what the next problem is? So give some thought. Yeah, we're going to have, well, I'm going to put you in a situation, if Lamar comes Friday, we'll do this kind of thing with what he's done with the campus network. If he can't make it, we'll continue on. The next time we do this, I'm going to put you in a world where you have to worry about that third dimension. Okay? See you guys. Okay.
Hey,
Sir.
how long before the end of the semester did you start to use when I had slides here?
Oh, yeah.
Oh.
Was it? I don't know.
I would recommend starting on this.
Well, he changed it. He changed it because, like, when I had him, it was different. Like, we had a group. Individual.
I'm doing this on this.
No, we had a group, and we were required to work in a group.
Yeah, like,
Or no, I'm in 307.
Basically, it was like we got an email memo that was like, "Hi, our company's vehicle management system is broken. You're a consultant for a fix-up problem."
I'm not.
oh, yeah, he's in my biggest fan. It's not really.
No, this is me.
Yeah.
That was just like.
Oh, guess I'll hit.
I was